described it as a data platform. I think for a lot of people, they would probably describe it as a stream engine or a processing engine. Is that correct?
This category is still in the early stage, right? So people all know what is database, what is data warehouse. Then people talk about data lake. The streaming processor part has been there for a long time. Like if you're familiar with Apache Flink, for example, that's one of the best open source. And it works well in many cases. And I think there's a huge developer community in Germany and in many of the rest of the world. However, Flink is designed in a very kind of elegant and complicated way, right? And it's not easy to get started with Flink. And if you set up your own Flink cluster, it's not cheap. It requires a lot of CPU memory, tuning, and overall experience of Flink is not great enough. That's part of the reason why maybe Apache Spark is a little bit more popular.
Hello everyone, welcome back to this week's episode of Simplyblock's Cloud Commute podcast. This week with another incredible guest. And yes, I know I say that every time, and you know it's every time true. So, hello, Jove. Thank you for being here. I think we never met before, so maybe just give me a quick introduction about you and your background.
Hi, Chris. I'm so glad to join the show. And yeah, my name is Jove Zhong. I'm the co-founder at Timeplus. So Timeplus is a streaming database or streaming SQL or streaming analytics, depends on what kind of category you're coming from. So we are essentially providing a very unique capability for you to understand what's going on right now and also what's in the past. Even you can do some machine learning, real-time training for the current data and the predictor for the future points. So we provide both the open source core engine as well as some commercial software on the cloud or bring your own cloud or self-hosting. And as a developer, you can connect Timeplus with your real-time data feed, for example, data in Apache Kafka, in some, for example, Postgres database, you can apply some CTC, and all those real-time data and historical data can be put into Timeplus, and you can just leverage SQL to understand the pattern, do some real-time and low latency aggregations, and this can be quite useful for any kind of use cases need a really low latency data points. For example, whether you are being attacked on the cybersecurity, or if you do any kind of trading in the traditional financial sector or doing any Web3 blockchain, you might leverage our system to understand, should I buy or sell more my portfolio given the past few seconds, the price, the momentum. So we are more like a general purpose data platform focusing on the real-time part, but can be applied to many use cases. And I'm happy to be part of the show and share my story and about some of the technical details.
Right. So you described it as a data platform. I think for a lot of people, they would probably describe it as a stream engine or stream processing engine. Is that correct?
Yeah, this category is still in the early stage, right? So people all know what is database, what is data warehouse. Then people talk about data lake, and the streaming processor part has been there for a long time. Like if you're familiar with Apache Flink, for example, that's one of the best open source stream processor, but it works well in many cases. And I think there's a huge developer community in Germany and in many of the rest of the world. However, Flink is designed in a very kind of elegant and complicated way. Right, and it's not easy to get started with Flink. And if you set up your own Flink cluster, it's not cheap. It requires a lot of CPU memory and tuning. And overall experience of Flink is not great enough. That's part of the reason why maybe Apache Spark is a little bit more popular, right, in the data world. Maybe in terms of the real-time processing or streaming processing, Spark is not as strong as Flink, but overall, Spark has much easier developer experience and nice integration with Python, for example, and also it's backed by Databricks. So if you are a Databricks customer, you have a better version of Spark, and you can do a bunch of other magical ML or data engineering stuff in the Databricks platform. However, we think we can do something better than Flink. At least this is our motivation as a startup company, and we also not just focusing on the processing part, but also we have our own storage engine. So it's okay. You can just send the data to us, and no matter it's fresh data or historical data, and we can leverage a single engine to allow you to ask questions about what's happening right now, and also what's the data trend or data pattern in the past 2 years. You don't have to send a query to different systems. Otherwise, you might have to send some data to, for example, Flink, and some other data to Snowflake, and you ask question and do some join will be very difficult. And we are a single platform to handle both real-time and historical data. So that's something we really want to make data engineering a little bit easier, especially you care about low latency and also need to join both the real-time data and historical data.
Right, and as far as I know, Timeplus is all about SQL. So you extended basically the standard SQL engine or the standard SQL syntax, and added streaming capabilities to build all the queries from source to sink, right?
Yeah, SQL is at the very beginning it's our primary, or even at the very beginning it was the only interface. And later on, we add a few more like user-defined function, UDF, and we can support no matter calling a remote service, or you can leverage JavaScript or Python to define your own logic. But all those customized logic is still defined as a function, as a SQL function, and you still put this back to your overall SQL statement. So, for example, like unlike compared to Apache Flink, which is based on the low-level API, and SQL is their kind of abstraction layer. So you write a SQL, but it will eventually compile or translate it to some low-level API. But it's not the case for Timeplus. SQL is our own API. There's no underlying data frame, whatever API. But we do realize that SQL can be very powerful. You can write a bunch of say CTE or subquery, but sometimes you do need to write more complex logic, or you can leverage your own JavaScript or Python libraries. So in that case, we enhance our UDF framework. So we can talk about that later, but that's really kind of something in the middle or more flexible way for advanced users to apply your own logic in your own SQL pipeline. So you can do many things, and it's very efficient. In many cases, the JavaScript engine we choose, which is Google V8, it is almost as fast as native machine code. So you don't really sacrifice on performance. But SQL remain the main interface.
Right. So you already mentioned a few use cases in the beginning, but what are like the big things? I guess real-time dashboarding, financing. I think you mentioned stock market. What are the big ones?
Yeah, sure. So in terms of the use cases, there's many things we can do. And to be honest, some of them, or at least half of them, many other streaming processor or vendor can do. So it's bringing to the kind of overall picture that is, there's a lot of common use cases. For example, we call it streaming ETL. That is, you keep moving data from A to B. For example, like you have your original transactional data in Postgres or MySQL, right? And all those data you want to create a real-time dashboard, or you want to create a real-time alert. Say if my average customer rate today is lower than 3, then you need to notify the manager, you do something. Or if you, for example, if certain area you are offering some service and certain area they have not enough goods or inventory, you might want to send some alerts. So it is very natural to leverage the other system, not the original Postgres, to do all the analysis, because you don't want to slow down your Postgres, right? So those are real-time CDC. It is very common, and also you want to do some real-time alerts. You want to build your feature store in terms of the machine learning, right? You want to grab all those original data source as many as possible, as fresh as possible, and convert them into a bunch of numbers. And this acts as a feature store so that you can apply more machine learning for your data scientist, data engineering team. So there's many things this industrial is focusing on, and there's also open source solutions, commercial solutions. But what's really helped Timeplus stands out is we are very focusing on the performance, and also its low footprint. So I'll give you an example that is many systems can do per minute or maybe a few seconds data movement or transformation. But in terms of Timeplus, because we implement in a special way, and we can easily achieve single-digit millisecond end-to-end, meaning that is when there's a data pushed to Timeplus, and with all those streaming processing or those CQ logic, we can show the results to the downstream or maybe trigger an alert, and the entire end-to-end latency is maybe 5 or 6 milliseconds. So this is quite useful in some of the scenario that is you need a really low latency, for example, trading or risk analysis, right? I mean, if you are just looking at the dashboard or some other kind of data consolidation, such a single-digit millisecond is nice, but may not be that really required. But for the case of trading, right? So it's a very competitive space, right? Everyone wants to be faster, and you don't have to be super fast, but as long as you are faster than others, you have a better chance to win or lose less money, right? So everyone push very hard to have the best network cables and the low-level package. They want to do everything they can do to achieve a better performance and lower latency. And it is true that is we work with some of the best financial companies or even some of the people in the blockchain or the Web3 space. They leverage our technology to get to the low latency, but also because we have this we call streaming CQ or materialized view, which is kind of a new concept to if you are not familiar with that. But essentially, it's a long-running CQ. It keeps scanning all the new data and send you the results, and the CQ itself is a background job. It never stops, and keep working on that. So using that way, you don't really have to set intervals. Like I want to query my system every 1 minute or every 2 milliseconds. You don't need to do that. You just define your logic in your CQ, and whenever data comes as low as like 5 milliseconds, you will get a result, whether it's a good signal or it's a bad signal.
Yeah, it's basically a table which is always up to date with the latest data that matched the query. Very useful stuff. I think in terms of trading with the high performance, it's probably mostly HFT. For people that don't know, it's like high frequency trading. Those guys are insane, like nutly insane. Like they, I mean, I think they sell in like they buy and sell in second orders. It's completely out of this world.
They don't really care too much about like what's the quarterly report or what's going on Twitter. They just look at the number itself.
Right,
and
exactly.
figure out what's the room.
I have a friend who's working a lot in HFT, and just listening to him is like, whatever, make your money. I'm glad. In terms of sources and things, you already mentioned Postgres and MySQL. I guess Flink, Spark, the common ones. Is there anything like very special that you say, that does work or that doesn't work?
Yeah, for us, the most preferred data source is Apache Kafka, right? Again, it's right now there's many other Kafka API compatible services, right? They talk to the similar or even the same protocol as Apache Kafka, but you don't have to literally use Kafka, but it's still very common for you to leverage Kafka to consolidate your data source. So, I mean, the point that is we don't have to talk to individual database, talk to individual API, and if there's already some integration to move those data to Apache Kafka, then we only talk to Kafka. That will be easier. And Kafka also supports a very nice kind of a schema registry or different data compression or retention policies. And today, for example, if you operate your own Apache Kafka, it's not so easy. So some people choose a manager service such as Confluent Cloud, and then also that's bring the room that is maybe some people complain Confluent Cloud is not cheap. So that's the reason why people like Rapanda or WarpStream, they come up with their own solution, no matter using Simplyblock or using Golang, or whether to use object storage or not.
Yep.
So they can bring down the cost low, but may introduce a little more other things you want to worry about. For example, whether the latency remedial requirement, for example, WarpStream may not provide as good low latency as others, but they do very good job on the object storage leverage, so it's much cheaper. Yeah.
Right, but that means if Kafka is your preferred data source, you either have your own connectors or you can basically connect anything that Debezium supports as well.
Yes, yeah, Debezium is very popular for so-called CDC, right? Moving data from the original TP or TP database and translate to the JSON format or similar format to capture what is changed. And Debezium can write data to for example, to a Kafka topic, and we can read it from there, and it's a very lengthy and compact structure. Say, what is my schema? Which column is changed? What's the before value? What's the current value? Then we translate it to our own, no matter it's a CQ or it's insert, and so that we can capture what almost the mirror in the real time what's happening in original database. However, the Debezium also can be leveraged, I guess, without Kafka async. In some cases, you can even leverage the Debezium as a library to fit into our system. But today we still focus a lot on the Kafka data sources. In the meanwhile, we also have our own REST API for you to push data to us without something in the middle. And this can be particularly useful if you have a few, for example, IoT devices, right? So the IoT devices, maybe they can send data to Kafka, but still it's you need some Kafka library. But sending pure pan HTTP requests, it's easier, and the template itself have own buffering or some of the mechanism so that you can send as many data as possible to us, and we can making sure those data can be analyzed in real time, and you don't really have to set up a Kafka. But if your organization already have Kafka, then perfect. Then it's really a nice way to consolidate your data, and we don't worry as a data engine. We don't have to worry too much about the consolidation part.
Right. From a developer's perspective or operations perspective, I know there's Timeplus Cloud. And as far as I know, you can also deploy it. I think there is even a homebrew, like a macOS homebrew version, but there's Docker images. There's everything. I mean, the homebrew version is great for developers who want to try it out, who develop on their own machine. There's literally like no easier way to get something on macOS. Maybe just talk a little bit about the different options. And what are the pros and cons between all of those?
Yeah, sure. So the motivation is simple. That is, we really want to make developer happy. At least let them less frustrated, right? I mean, being a developer is not easy, and you have to read a lot of documents, and you have to set up dependencies. And for example, on my machine, I may have 10 different JDK versions, and depends on which software I use, I may have to keep a switch. Even sometimes I have to switch different Node version or the Maven versions. There's a lot of complexity in the developer world, and we want to make things as easy as possible. So we want to provide different options. We have this core engine open sourced on GitHub. We call it Proton or Timeplus Proton. So this is our core engine, and it's as simple as a single binary. I think when you get it, depends on your Linux or Mac, you might have this 200 or 300 megabytes, a single binary, a single file, and you just change mode plus X, make this executable, and you can run that. There's no other way. That is, it's super easy. But we also provide things like Homebrew, so that you don't have to download by yourself, just using Homebrew. I personally run, I guess, brew update every other day on my Mac to make sure all my software is up to date. It's more like clean up. It's cleaner than my room, I guess. I want to get to the latest room. It's very easy for you to get to the latest version using Homebrew. And also we have, for example, Docker image for sure, and you can also install our software using curl. It's a script. But more importantly, that is, if you want to run this in production, and we offer we have this fully managed cloud. So you just need to log in with your social account, no matter it's Google or Microsoft. You can just log in, and you may get again, you can see some of our live demo systems. That's for sure. But if you want to try by yourself, you can jump from your demo system to our cloud system, and you can get a free trial for 14 days. Then that's fully managed by us, and upgrade by us, and tuning by us, and it's easier for sure. But if you want to do the self-hosting by yourself for different reasons, for example, like you have your Kafka in local, you don't want to expose your Kafka endpoint to the internet, or you have some other databases, you want to have some data who are not ready to be put on the cloud. So you can feel free to use our self-hosting version. We do provide Kubernetes Helm charts for you to install easily on your Kubernetes. Or if you want to just set up 3 or 5 different virtual VM, and you can install the binary and configure them to create a cluster by yourself. So all those options is available, and it really depends on the use cases. For example, we have normal customers who use the Kubernetes, the Helm chart. That's very easy. But we also found some users, they just need to run the software on a small server, or even kind of a single node, and they have a lot of that. So it's more like similar to the edge computing, right? Each server, they have access to certain files, and they want to react on it quite quickly. Even we do have some even more classic edge scenario, which is we have some clients doing POC with us. That is, they have a lot of a train. I guess like on the train, and you not always get good signals, right? For example, if you are in the countryside, if you go through some tunnels, so you do not always get good signals. So they prefer doing the computing on the train. So every single train, they have a bunch of small devices, and the devices only have limited resources, like for example 8 core and maybe 16 gigabyte memory. And in the past, they want to put everything together. Like they want to put Kafka, they want to put Apache Flink, they want to put ClearHouse, they want to put Redis together in such devices, and it's bringing a lot of issues. And now they can just put the Timeplus, and the Timeplus is a very efficient engine, and they can do on-device monitoring, training, alerting. Yeah, so that's there's a lot of deployment options for sure, but yeah, feel free to choose which one you think works best for your scenario.
All right. You said Timeplus Cloud. Are you using Kubernetes internally? Is it the same Helm chart?
Not really Helm chart. So I guess again, people might have different opinions, but in the practice of Timeplus, we use our own Kubernetes operator in the cloud. Again, it's Kubernetes, but we use literally it's EKS, right? AWS managed Elastic Kubernetes service, I guess. So the reason that is we also want to minimize our operation efforts. So for example, the master node of Kubernetes is managed by AWS, and they also have something like Fargate, right? You can less worry about the infra, the VM stuff, and the AWS also they don't really provide most recent or latest Kubernetes version, but they do a lot of tests and they have a bunch of plugins. So we're happy to be using EKS. But the reason why we not directly using Hamcha, but using operator, because we also want to handle multi-talent and some other things better. And using operator essentially is customized code, right? So you can write your Golang code in operator, and when someone sign up, when someone upgrade, we can do extra things. And Hamcha is really designed for people who don't care too much about multi-tenant. They just want to set up a multi-node server, and Hamcha just have a bunch of template parameters, so for you to wire things together.
Yeah,
but essentially they are same.
Yeah, that makes sense. We're almost at the end of our time. One question I always ask people, like, what do you think is like the next big thing? What do you see on the horizon? Be the visionary. Could be in Timeplus, could be in stream processing, could be in databases, AI, whatever you think is cool.
Yeah, I will say certainly AI is a big thing, right? Some people think there's some bubble. I have my own opinion, but I guess there's something we need to do together, that is making sure AI can get the latest fresh data, cracked data, right? I mean, they do usually don't do this very well. They have a lot of kind of historical patterns, but they don't really have good access to the fresh data. That's how data AI and the data can get together. And even not talking about AI itself, there's a lot of movement today to have cloud native data warehouse or Esper or something like that. People can put more data in the cloud with relatively low cost. But step by step, people will be realizing that I not just need a huge amount of data, I need to understand what's going on right now. So the real-time data, the streaming data, I think will have a bigger room to grow. And with the AI, we can even somehow partner with the AI engine or AI model to come up with a better context and provide a better recommendation for the human.
All right, I think that makes a lot of sense. I also feel like machine learning plus real-time analytics data is probably the next step, integrating those two things. And it happens a little bit already, I think. Like a lot of the what's it called, fraud detection algorithms are basically using some kind of pre-trained AI model or machine learning model, and feed the current data for it. All right. Cool. I think that is nice. Anything else you want to put out? Anything you want to share with the world?
Yeah, so I'm wearing the t-shirt Timeplus if you are watching the video, but if not, just go timeplus.com. I think there's some button to allow you to try either our open source version or the free trial version on cloud or on self-host. If you are a GitHub user, if you can give us a star on our portal project, that'd be great. So give us some feedback to raise your requirements, report some issues, or help us on the documentation, or just chat with us in our community Slack. You can learn more people, different use cases, and help each other to build a better world together with fresh and cracked data.
That's awesome. I'm happy to put all of those links in the show notes. If you want to find anything, you'll find it. Jove, thank you very much for being here. It was a pleasure having you. I hope we see you at a conference somewhere soon.
Yeah, of course. Likewise.
I think for the first time, I think we never met in person, but for the audience, you know the drill. Next week, same place. And I hope you come back and listen in again.